Good morning, good evening, good afternoon. This is Panama Bartholomew with the Building Decarbonization Coalition, and welcome to BDC Presents, our monthly webinar series, sometimes more than monthly webinar series on the hottest topics and the best speakers in the world of building decarbonization. We have a really great one today. The California State University system, largest four-year university system in the galaxy, is here to talk about their building decarbonization plan, their master plan for decarbonization. How do you take, how many, Rachel? 20 some? 23, how to take 23 campuses to carbon neutrality. It's amazing. You're gonna hear from some great speakers talking about this plan and lessons that we can learn from their planning efforts. But first, you may be asking, who is this BDC? The Building Decarbonization Coalition is a nonprofit coalition made up of utilities, manufacturers, the design and construction community, local governments, NGOs, and a whole bunch of other organizations and individuals that come together to collectively seek to eliminate pollution from the built environment through working with the market and policy leaders to bring about the changes we need for full pollution elimination. I have a little lag in my, here we go. And in 2019, in an effort to really outline how California could reach this full pollution elimination, we adopted a roadmap. And that roadmap laid out a series of numerical goals for California to meet in order to be able to achieve it. We said that we have to stop the expansion of the gas system through building codes for residential and commercial buildings no later than 2028. And we need to implement a series of programs that lead to an overall reduction of greenhouse gas emissions in the built environment through strategic investments and the turnover of appliances from fossil fuel powered appliances to high efficiency electric appliances. And inherent in that was a belief that if we're trying to hit carbon neutrality for all sectors, including buildings by 2045, that math leads you to the reality that if our appliances have about a 15-year lifespan, we can't really be selling fossil fuel appliances many more after 2030. And so we adopted some targets as a coalition that said by 2030 we should be phasing out the sale of fossil fuel appliances. Inherent in being able to reach those numerical targets, though, is an understanding of some changes that have to happen in the political and market sphere in order to make that happen. And so we also adopted these goals. Number one, really raising awareness across the board. Policymakers, consumers, installers, builders, like everybody has to have a better understanding about the benefits of electrification. We need to make sure that the people that are electrifying their homes, their businesses, their institutions are receiving a good value proposition out of it, that the capital costs and the operating costs result in a better situation for them than if they had stuck with gas. Additionally, we need to be able to build sustainable market off of this. We need to be able to have people be able to make money, and builders and installers and the design and construction community and critical consultants are able to make money off of building decarbonization for this to work. We need the supply chain robust, ramped up, ready to go. Part of that is us sending a clear message about the rate of change, but part of that is also us getting barriers to the supply chain out of the way, like undersized electrical panels, lack of quality infrastructure. And lastly, we need to align all of our policies. We're not going to be able to meet our climate goals, our energy efficiency goals, our building code goals, if all of those policies are actually out of alignment with each other and are conflicting with each other. And so this webinar series is part of goal number one. Really, it's building awareness. And as one of the ways the Building Decarbonization Coalition seeks to build awareness by bringing in some of the top speakers that are working at the cutting edge of our space to be able to talk about what they're working on, lessons learned, and to be able to create a conversation and continue a conversation around building decarbonization within our community. So thank you for joining us for a fantastic one today. Coming up, we have some very exciting news. We're going to spend the next 3 months focusing on extreme heat and the role of building decarbonization in reducing the impacts of extreme heat. All of us just went through a pretty brutal summer, and unfortunately, I think no news flash to folks on this call, we probably have a number of those summers coming up. And so how do we alleviate that? You know, there's long-term and short-term solutions in that, but building decarbonization through the installation of high efficiency cooling equipment needs to play a critical role. And so we're going to have a 3-month webinar series that's going to bring in OEMs, it's going to bring in political leaders, it's going to bring in people that are working at the front lines and communities to help with dealing with extreme heat. It's going to be a fantastic webinar series, and look for our next newsletter to be able to find out more information on that. So just some reminder, we had just about 200 organizations register for this event, so I'm sorry, but not everybody can be off of mute. We're keeping everybody muted. Please ask your questions via the chat or the question and answer boxes, and we'll make sure that we will at least attempt to get to them by the end of the presentation. This webinar is being recorded, and if you're a member of the coalition, you will have access through our member portal to be able to get both the presentation and the recording. And you also get a lot of other great benefits from being a member of the coalition. So if you would like to join us, buildingdecarb.org/join is a fantastic way to see all the benefits we offer for membership and what you can get out of it, not just our wonderful past presentations. So with that, I'm going to hand it over to the CSU team. We have just a fantastic group. We have Rachel Wong, who I'm going to throw it over to with the CSU Chancellor's Office, Andrew Meiman from ARC Alternatives, and Brian Stern from Glumac, and they're going to walk you through the development and then the current state of the CSU's Building Decarbonization Framework. So thank you all so much for joining us. Really looking forward to a great conversation, and take it away, Rachel.
Thank you so much, Panama. Let me see. Are you able to see it full screen right now?
We are.
Okay, now I lost the PowerPoint screen, so let's figure out how to get that back. There we go. All right, good morning, everyone. Thanks for hanging out with us. My name is Rachel Wong. I'm the Associate University Engineer at CSU's Chancellor's Office. Andrew and Brian, if you want to introduce yourselves as well.
Sure. I'm Andrew Meiman. I'm a founding principal at ARC Alternatives. We're a small California-focused clean energy consulting firm.
Brian Stern, Regional Energy Director with Glumac. We're an MEP engineering, sustainability, and energy consulting firm, and excited to be here with you today, and turn it back over to Rachel to kick us off.
Awesome. So I'm going to give you guys a little bit of background on the CSU, because it sounds like there's a good geographical spread of folks here. So we do have 23 campuses, largest public university system in the country. As to Panama's claim about largest system in the galaxy, I have not fact checked that, but we're pretty big. So really sort of great diversity of climate zones, of staff capacities, of the types of students that we're dealing with. So it makes this a really interesting challenge when we're talking about decarbonization, as well as really any other large scale endeavor. So we serve about 486,000 students, have about 4 million living alumni, lots of, like I said earlier, ethnic and economic diversity, and something that we take quite seriously that I'll sort of re-up a couple more times over the course of the presentation, is that we have really high rankings for upward social mobility. So that affects how we want to approach big projects and rollouts like building decarbonization. You know, we want to make sure that's cost effective so that folks can sort of channel their energy towards graduating our students on time, making sure that there are minimal interruptions, that they're excuse me, that they're getting the sort of world-class education that they signed up for. And something else that's pretty exciting is that campuses are typically keystone institutions in their communities and their municipalities. And that is something that we take very seriously. So when we're talking about the sort of technical aspects of decarbonization, we should probably give you a little bit of background on what the general outlook of our facilities are. So lots of square footage across our 23 campuses. We have around 2,000 buildings. On average, they're about 30 years old. So when we're talking about decarb, you know, if we get a new building this year, it's still probably going to be around in 2050. So Not only do we need to make sure that we are decarbonizing on time, we also need to make sure that it's going to be operational and comfortable in 2050 for that climate then. We're growing pretty rapidly. Some exciting news is that we are getting our third Polytechnic University. Our existing ones are at San Luis Obispo and at Pomona, and now Humboldt is going to be the third one to be added to that slate. And, you know, outside of the, and I believe Panama, you said that you are a Humboldt alumni. So really exciting stuff. So yeah, even outside of that, our campuses are consistently growing. So that is something that we keep in mind. And as for the central plant types, because the way that we're, excuse me, approaching this building decarbonization framework is targeting the heating hot water temperatures. A good amount of them are really centralized in terms of both heating hot water and chilled water. A few of them are hybrid and a few of them are steam. So those steam campuses, you know, we want to first concentrate on converting them over to heating hot water, and then getting them to a lower heating hot water temperature. So the way that we've dealt with climate change to date is that we sort of have to do the mitigation simultaneous with adaptation. Something that we felt really acutely over the past few years is, you know, we're getting public safety power shutoffs, we're getting hit with wildfires, we're having to deal with drought. And so we have to sort of craft our overall strategy to deal with all of those things head on. So one of these things is obviously the Building Decarbonization Framework. Something else that we're working on for those campuses that are dealing with PSPSs and wildfire is planning out a microgrid roadmap. So how do these campuses, we're not able to build out the microgrids to cover the entire campus, but we want to make sure that if they're hit with this type of a situation, they can recover as quickly as possible and in a cost-effective manner. Something else, like I mentioned, you know, on average 30-year-old buildings, climate adapted design days framework, that's going to make sure that we build our buildings as well as our infrastructure to be able to deal with the climate of 2050 and on, you know, if the building or infrastructure stays around longer than that. Utility and energy master planning obviously goes into that as well. And we also want to continue to focus on energy efficiency projects, demand flexibility, localized DER capacity, as in building out more solar and storage. You know, we want to keep all the tools in our tool belt, not really limit ourselves to any one strategy. And today's presentation is part of that. And so this is a little bit of an overview of how we're doing with our emissions nowadays. This data is up to 2015. And we have a system-wide goal of getting an 80% reduction from our 1990 emissions by 2040. So as you can see, you know, those bottom couple of layers of natural gas and cogen, decarbonization is going to target that. In terms of our purchased electricity, that's obviously a contributor as well. But as the grid gets greener, as we build out our solar and storage, we're hoping to, and energy efficiency goals, you know, those are all ways that we can target on getting to that 2040 goal. So we have 19 years left, pretty aggressive, but we're chugging along. You know, we're trying to roll all of this stuff out as quickly and as seamlessly as possible. And so the way that we approach this framework in our work with Glumac and ARC Alternatives is that this slate of documents, we're hoping to get it on the table with our energy managers, facilities officers, sustainability managers, so that they can then take it to their leadership or whoever is sort of managing these projects to include the decarbonized option. So it's a continued educational campaign. It's a continued reorientation of, oh, okay, we can't just keep replacing like for like. If you're looking at a gas system that needs renewal, or if you just need to replace a boiler, or, you know, if you're looking at coils that are worn down, do we have opportunities there to sort of move the decarbonized electrification forward? Obviously, you know, with how CSU does things, we need to make sure that's cost effective, need to make sure that's maintainable, and it's not sort of an undue burden on the folks who run our facilities day to day. And we need to make sure at the end of the day that this works for the CSU. What works for the CSU may not work for the UC and vice versa. So we need to make sure that we are avoiding stranded asset risk, climate risk. We're accounting for campus diversity. You know, we have 23 campuses, and sometimes, you know, that means that folks do things 23 different ways. But we are here to sort of provide a floor, a foundation for them to work off of, and encourage the proactivity of how we're approaching these projects. You know, look at deferred maintenance that's maybe coming up, or you know, capital projects. You know, just changing the conversation. That's what we're trying to start to do with this educational campaign. And so as for the framework itself, it is comprised of a number of documents, which Brian and Andrew are going to dive a little bit deeper into, but we broke it out into 3 main buckets of resources, guidelines, and tools. And it really covers, I think, has a really holistic approach for how folks can, you know, sort of set the stage and then start thinking, give them ideas to brainstorm around, and then give them the tools to then take to leadership to make these projects happen. And over to Andrew.
Great. Well, as you might imagine, we started this framework exercise and setting the stage for the framework with a policy report, and a high-level one. It's short, and it really focuses on the policies that are driving the decarbonization efforts for the CSU. At the state level, there's 2 main ones, which I'm sure a lot of folks on this call are more familiar with than I am. But in 2018, there are 2 key ones that were enacted. One is the Senate Bill 100, which requires the zero carbon grid by 2045, and the other is the governor's executive order, which also is 2045 date to achieve statewide carbon neutrality. And since CSU is one of the, you know, sort of branches of the California state government, they are, you know, lockstep in this with the state and going toward this goal. The system-wide goal for the CSU itself, is, as Rachel had mentioned, is a 2040 goal to be 80% below the 1990 levels, which builds on previous goal of AB 32, which I'll talk about in a second. And then, you know, when you kind of get down to the campus level, they're very active, and they have, again, their own goals, 23 different ways of doing things, but, you know, all marching in generally the same direction. 22 of the 23 campuses have active ASHI stars ratings, and 90% or a little above are gold or silver. And so when you start getting those gold and silver points, you know, you really are earning points for climate and energy and sustainability. So they're all very active in this space. And of course, this is all happening within California's regulatory environment, where we are, you know, shifting to, or have shifted to, in some cases, the time of use rates across the board, and we have building codes for electric buildings, our Title 24 energy compliance, you know, which Brian is actually going to mention as part of the framework as well. So that all adds up to a lot of policies. That some of these policies have been in place. Next slide, Rachel. They've been in place for a while, and their predecessors certainly have been in place for a long time, and the CSU has made a lot of progress over the years toward these. So in some ways, this isn't all that different, other than the new, really renewed focus or concentration on carbon and the tools to help campuses think about carbon and achieve some specific carbon goals. As I mentioned, the current goal of 80% below 1990 by 2045 is, or by 2040, is step 2 of this 1990 by 2020 requirement, which was the original AB 32 goal in California. And the CSU, along with many other state agencies, met that goal early, primarily through decarbonization of electric supply already to date. Another big area of progress, CSU and UC are part of a statewide energy efficiency partnership with the investor-owned utilities and public-owned utilities. They've done a ton of projects over the years and saved tons, 730,000 of CO2 equivalent of GHG, just the CSU in that one. There's some new and exciting programs that are also sort of helping us march in this direction. One of them is a clean energy optimization pilot, which is a pilot program in SoCal Edison territory, where everything behind the meter, energy efficiency, renewables, electrification, storage, counts toward anything that reduces carbon behind the meter is game for an incentive. And that program is underway at 6 campuses, 2 of which are CSUs, Dominguez Hills and Cal Poly. And so this is an exciting carbon-focused pilot that actually just also won, we've heard, the Alliance to Save Energy's Innovative Stars for Energy Efficiency Award this year. And then again, the individual climate action plans and activities at the campus level are something that's ongoing and active. To put these policies in progress into a little more context graphically, we have this chart here that shows sort of where we've been and where we're going, where we need to go. In 1990, that first bar, you can see the just over 400,000 tons of GHG emission. That's kind of the benchmark. By 2016, it'd come down a little, reflecting the electrification and the cleaning of the electric supply. We're still at about that level, more or less, the 2016 levels. By 2040, the SB 100 kicks in. That's the carbon-free power. And so you can see that dotted chunk there in that third bar. That is the benefit that we're going to see from the electrified grid, and the clean grid, I should say. But what's left, as you can see, is a lot of natural gas. And that's where that 2040 target, that last bar and that gap is what we're really trying to get rid of now. We're trying to focus and displace that carbon emission associated with that natural gas, which means decarbonization. So to borrow a phrase from one of your previous presenters from another session, Sal Griffith, he said, we can't efficiency our way to zero carbon, and that's just so true. So, that's what this framework is trying to do, is trying to kind of change the game and let the campuses, or give the campuses tools to make progress toward that zero carbon. Brian's going to give us now a little bit of dive into the framework a bit more here.
Thanks, Andrew. I think, so the focus of the Building Decarbonization Framework was really centered around existing infrastructure within the CSU system, and specifically around natural gas systems. Most of the CSU campuses were built and established in the 1950s and 60s, have a lot of original infrastructure and buildings. And the challenge of decarbonizing, buildings that were 50, 60 plus years old can be daunting and overwhelming for facility staff. So the CSU Decarbonization Framework tried to establish a framework for how to approach this and how to think about this as a long-term effort. Starting first with an assessment and planning. How should you be establishing goals and key performance indicators on campus, and how should you be engaging in a carbon-centered planning process? The framework also focuses on load reduction. This doesn't change key strategies around reducing heating demands, reducing energy, and still prioritizing energy efficiency, but knowing that electrification is going to be critical in order for the CSU to meet their climate action goals. So identifying, what are the near-term projects that make the most impacts, and then over the long term, how do we optimize those higher efficiency assets and work towards a long-term electric solution, while making continuous improvements around retrofits, controls updates, resetting hot water temperatures, and phasing out gas equipment. And so the framework provides these resources. Without going into the detail of all of the documents and all the resources that were developed, we just wanted to pull out some of the key strategies that CSU will be looking towards in order to roll out this framework, as well as support the 23 campuses. And the first is centered around education and developing a familiarity with new heat pump technologies. Most, I'd say all of these campuses currently operate on primarily natural gas heating. So I wanted to provide resources around new heat pump technologies. So the design guidelines and technology review provides a holistic overview of all of these technologies and what is the key information that a facilities manager or energy manager would need to know. So for example, in an air source heat pump, understanding that 130 degrees is the maximum for a typical, going to 145 is possible, but that's going to increase the cost of that equipment by about 50%. So we pulled out some of these information and into a technology review that's a resource to educate stakeholders on CSU campuses. The next is to establish climate adaptive design criteria. So within this project, we looked at, as an example, Long Beach, California, where the Chancellor's Office headquarters is located. Looking at typical climates from 1961 to 1990 compared to the actual weather conditions in 2015 to 2020, we found that there was significantly less heating, with a 50% decrease in heating degree days and a 200% increase in cooling degree days. And that is a direct proxy of how much cooling and heating is required. And you can see that shift over time looking at the weather files. And this is something I think we've seen on coastal climates that has been a higher impact, and strategies that CSU are looking to are now developing a climate resiliency design guidelines that'll support future planning efforts. Part of this project was also to develop more carbon-focused infrastructure planning process. So the CSU system has a critical infrastructure reporting that happens on a 5-year basis. So the decarbonization framework feeds into their existing planning processes to help campuses better understand their existing infrastructure, inventory natural gas equipment. And that's important in the way that CSU operates. When equipment fails or there's emergency replacements, want to have plans in place to replace with a electric solution rather than a like-for-like replacement for natural gas equipment, and avoid additional investment in stranded assets, and really work and develop a long-term phased transition plan. By understanding the long-term goals of the campus and the direction, that helps with finding ways that new buildings or retrofits can support that transition. So for example, a new building on a CSU campus could include heat recovery chillers that serves a quad or a portion of the campus. So finding those opportunities for funding that is available is important, and having that long-term plan helps design teams to understand how their buildings or how projects on campus can support the overall vision of the campus. Another key CSU strategy is to prioritize heat recovery. Most campuses have central chilled water, central heating hot water, or steam systems. Heat recovery is the most efficient way of producing hot water, with efficiencies between 7 and 4 COP depending on the temperatures. And they also, heat recovery chillers can supply up to 170, 175 degrees, which is critical where a lot of campuses were designed around high temperature heating hot water systems, up to 250, 300 degrees. And this can be supported in both cold, typical, and warm climates. With the typical CSU campus, we see around 70% of the overall campus's central heating can be provided from heat recovery. The next is to then optimize around thermal energy storage and false cooling. Thermal energy storage includes chilled water, heating hot water, and also strategies around domestic hot water. Can we upsize storage tanks to shift loads? Can we use swimming pools if there's a recreation center, and change the schedule of when heat exchangers or heat pumps operate to shift loads when we have excess cooling? And then also optimizing with economizer false cooling, which is a strategy of capturing waste heat from buildings through the chilled water system and repurposing that to be hot water. With those strategies, we can increase and reduce the reliance on existing boilers. Thermal energy storage and false cooling for most campuses can provide around 20 to 25% of additional heating demands on the campus. And then finally, supplementing with additional heating sources. These are typically more expensive or more challenging. So really that's used for those peak design day conditions. And that can comprise of either geothermal, sewer, wastewater heat recovery, recapturing heat off municipal water, solar, building exhaust, or additional heat pumps and boilers. We're really focusing on what are the most cost-effective and efficient strategies first, how to optimize those, and then look to additional heating sources as a long-term to fully decarbonize existing systems. Part of the way this can be more economical is to reduce heating hot water temperatures. So that's also a critical aspect of the framework of reducing hot water temperatures, which helps to reduce distribution losses. It also supports heat pump technologies, which can only supply at lower temperatures with air source heat pumps around 130 and heat recovery chillers around 170 to 175. Also improves the efficiency of those. So for example, an air source heat pump with 50-degree air outside can have a 25% savings if we can reduce that water temperature to 115 from 145. So there's a significant efficiency benefit. And also looking at strategies around cascade heating for higher temperature buildings. There are buildings at CSU that will require heating higher hot water just due to the existing infrastructure. But we don't want an individual building to prevent the overall campus from reducing hot water temperatures and supporting the overall loop. So we can look at additional heating, whether it's an electric boiler or water-to-water heat pump that can boost hot water temperatures at individual buildings. CSU campuses have been very successful about resetting their temperatures. So for example, Dominguez Hill's hot water system was originally designed at over 200 degrees. They now currently operate at 160 to 170 in the winter and down to 130 in the summer. So I think it's been shown that we have the ability to reduce hot water within the existing infrastructure. And I think it really comes down to finding a process for both testing at buildings and at individual and at the overall campus to support heat pump technologies in that long-term transition. Another important strategy is to right-size equipment and then implement high-impact projects early. This graph shows a heating distribution of a campus located in Southern California. You can see most of the heating is significantly lower than what the plant capacity. The plant was designed around 13,500 kb2s per hour and peaks around 12,000. If we can provide 25% of the plant capacity with a heat pump technology, we can reduce the natural gas by 75%. I think what's part of this is how can we implement these high impact projects early to reduce our emissions as quickly as possible, and then really focus on a long-term plan to address those the peak design conditions, which are going to be more challenging and more costly to chase. As part of the project, we provided a simultaneous heating and cooling study for the CSU for all 23 campuses. I think what was beneficial about working at a system-wide level was the ability to scale and provide a single work stream. So we collected data from critical infrastructure reports, data from 23 campuses, whether the building automation system or energy information systems, weather data, provided and consolidated that data, and then we're able to provide benchmarking and regression. So for campuses where data was missing, we could use data from existing campuses that's weather normalized to fill in the gaps, and then created a singular tool that energy managers and facility staff would have access to understand their load profiles. I think this process of working at a greater scale, whether it's multiple buildings, multiple campuses, really helps to reduce our cost ultimately as consultants and be more cost effective for clients. The tool that was developed was a Power BI dashboard that helps to show the heat recovery potential across an individual campus. So this is a screenshot of a video of that tool. You can see on the right, there are key performance indicators. The center of the graph shows the cooling load profile in blue and the heating load profile in red, with the darker color in the center showing the potential for heat recovery. So that darker color represents what could be provided from a heat recovery chiller. The key performance indicator that we're really focused on is the heat recovery percentage. So what percentage of the heating demand on campus can be provided from a heat recovery chiller. So for this campus, for example, that's 72%. The dashboard allows you to drill into individual data, see how the load profiles operate on an hourly basis across a given time. So this shows the winter, where at certain times we have excess heating and also excess cooling during the afternoon. We can adjust heating hot water temperatures. So really trying to provide
Did we lose Brian?
Yeah, I'm not hearing you, Brian.
Audio.
Hey, Brian. lost your audio.
You can go to the next slide, Rachel.
Oh, okay. He's back.
Great.
Everyone else hear him? Okay, yeah, I think we lost you for a second. Hold on.
Can you hear me now? Cool. So looking across all 23 campuses and taking that up to a system-wide level, found that with heat recovery, thermal energy storage, and false cooling, we can reduce the central plant natural gas by 82%, which would account for a 12.7 million therm reduction, and reduce annual emissions by 67,000 metric tons of equivalent emissions, and really take a significant gap out of CSU's emissions profile to meet their 2040 target. We did find that central utility plants alone won't get them there, and really also need to focus on building decarbonization around heating domestic hot water, as well as individual building systems. But overall, heat recovery is definitely a strategy that is going to be critical for CSU to meet their climate action goals. Part of CSU's mission of being a goal of this strategy is to be cost effective, and Andrew's going to now walk through a tool that was developed to support energy managers to find cost-effective solutions.
Right, so we're of course dealing with engineers, and we're also dealing with finance people, a lot of the decision makers and gatekeepers here. And what do they like? They like numbers. So we wanted to, or needed to, get a way to get these numbers on the table early and get the decarb option on the table with the decision makers during the sort of a pre-feasibility stage. And the way we, the tool we developed to do that is a life cycle cost analysis tool. The approach here was really a balance of complexity, usability, and flexibility. The 23 campuses, all these different solutions, we had to sort of walk a line to get a tool that's useful, but not overly complex. So the approach was to build something where users could draw a boundary around the systems that they want to investigate. That we actually have to rely on the users a little bit to characterize the options based, rooted in the strategies that Brian's talked through in other documents. But we joked during the development of this that we could only build so much intelligence into the tool itself, and that this is not an AI or anything. It's we have to have an intelligent user in the mix here still. But the tool does provide a consistent analysis and approach. It provides standard assumptions. It provides checks and balances and some guardrails, so you sort of avoid some of the common traps, or you don't want to do something that sets the campus's peak load if you're electrifying and not realize you're setting the campus's peak load. But basically you're doing things in a consistent way, and in particular the output of this tool is consistent, usable, and it enables you to compare multiple scenarios across life cycle and annual. So the next slide is really just a overview of the structure of this tool. It's an Excel-based model. Those first two green lines here, that's kind of the meat of it from a user's perspective. The input tab is that first tab, and it's really a guided narrative approach. Again, rooted in the strategies and technologies that we fleshed out in other parts of this framework. But it guides the user through some entries, and then out pops the life cycle and annual summary of the modeling results. Everything below the green boxes there is sort of the guts of the model that just kind of cranks through and has some lookups and calcs and references for consistent outputs. Then the next slide shows a snapshot of some of these outputs, and you've seen one of these graphs before, but really, this is just part of the output page. Couldn't squeeze it all into one slide here, but the takeaway is this enables users to evaluate multiple scenarios for decarbonization options against the business as usual case, or even against a fossil option, if you will. And it looks at all of the, it expands the dimensions of what you're looking at to make a decision, and it's annual and life cycle cost, maintenance costs, commodity costs, first cost, the commodity use levels themselves, and the GHG, what is this thing pumping out and what are the costs associated with that? So it really gives a full picture. That's the idea here, is to get options on the table and provide a full picture. Now, Rachel will talk a little more about the implementation pathways once you have this picture.
Yes. Let's see. Okay. So essentially, we have all of these documents that Andrew and Brian helped us develop. And our worst case scenario is if they sort of just sit in the cloud somewhere, gather digital dust, and they don't see the light of day after that. So over time, we sort of marinated on all of the information that was given to us, probably much like you guys are doing now, because we've just thrown a lot of stuff at you, and thought, okay, because where I sit in the Chancellor's office, it's under CPDC, which also stands for Capital Planning, Design, and Construction. I'm in the Energy, Sustainability, and Transportation unit. So I'm thinking through, okay, what are the tools that we've seen for previous renovations, new capital projects that we can actually leverage to get decarbonization going, to get some momentum there? And this is kind of the first list that we've developed there. And oftentimes at the CSU, we say that the Chancellor's office is in the programs and platforms business. Our campuses are the ones that actually make these projects happen. And so we said, okay, this is what you can leverage to move decarb forward at your campus. And so here are some case studies of folks, campuses, energy managers, facilities teams, along with their engineers and architects who have made significant strides in terms of decarbonization. With new buildings, it's kind of a different challenge than an existing building retrofit, which can get a little bit more complicated depending on the sort of boundaries the constraints that you're working within there. So at Long Beach, that one's already been constructed. I believe they're moving in already. At Northridge and Chico, those are still in design, but we wanted to take this opportunity to showcase some folks who have done things quite well at their campuses, and can hopefully inspire other CSU campuses as well as you all, that we can really be ambitious here, even while trying to be cost effective, while working within, okay, we have pretty old campuses. How can we sort of move that ball forward? And then on the infrastructural end, these are a couple of things that have already been existing. So what you're working within there are retrofits or operational changes. And the one on the right with demand response, that isn't even sort of strict decarbonization as we would maybe frame it nowadays, but demand response, energy efficiency, trying to leverage all of those things that you have on hand from your day-to-day is really critical. It's something that we want to continue to encourage our energy managers and facilities folks to do. And so, I think shouting them out and giving this visibility is a good way of doing that. On the left side, you have Monterey Bay, who installed a heat recovery chiller in their central plant. And sometimes, if you think back to that one graphic that Brian showed about targeting that, maybe right sizing it to 25%, basically targeting that 75% reduction first. And then if you need to do sort of a hybrid solution for now as your phase one and make it cost effective and just keep that going rather than just stopping, then having a really cost ineffective project on your hands just because you're trying to make it all electric all at once, that's also a solution that we support. And so essentially, going back to this graphic that you saw a different version of a little bit earlier, we have a long way to go, 19 years to get to our 2040 target, but we're hoping that, with all of the tools and especially with this decarb framework that we've shared with you today, that we can get there on time. And with that, wanted to open it up for some questions. I've linked this framework, which I imagine we'll distribute the PowerPoint after the fact. And thanks so much.
Awesome. Thank you, Rachel, Andrew, Brian. Fantastic presentation. It is so encouraging to see an institution at a scale like this that actually has their act together and has put together a fantastic team like you three, and I'm sure a number of other colleagues that are working on this, but really inspiring, really exciting. And just great just to be hearing institution after institution just saying, yeah, we're electrifying because that's what you got to do, and we got to decarbonize, and just here's the plan. So really fantastic, and thank you so much for that presentation. A bunch of questions. Looks like we got a bunch of engineers on the call based on the questions. So I'm going to start throwing them over to you, and I'm going to also maybe unmute some folks as well on this. And so first of all, I just want to ask two questions from one of the longtime leaders in the space, Michael Winkler. And here are the two questions. In Humboldt County, we worked with PG&E during the power shutoffs to island the county from the rest of the grid while using local power plant to operate as a mini grid. Has the CSU considered a similar approach in areas surrounding the other CSU campuses? That's the first question. Second question is, has the CSU considered using multifunction heat pumps to maximize efficiency, combining air conditioning, domestic hot water, and refrigeration?
Okay, I can grab that first question. I'll probably throw the second over to Brian, as he has some on the ground experience to pull from there. So number one, yes, absolutely. We're working on our microgrid roadmap on a system-wide level to basically captured some of the lessons learned from some of our campuses who have been most heavily hit by PSPSs. So that includes Sonoma. Sonoma State is microgridding up. San Bernardino is looking at that as well. Even Humboldt State or Humboldt Poly or whatever they're going to call themselves, they are looking into microgrid options as well. And we're hoping to, use those as case studies, because we have to move from pilot projects into a program. That's how we sort of see that formation there. Yeah, hope to formalize it in that roadmap, which will be coming, I think, sometime next year. And the second one for Brian, I think.
Let me know if you want me to, Brian.
Yeah, I guess regarding the multifunction heat pumps, that's certainly something that, campuses should be looking at and can be looking at. I think one thing that is interesting in the way that CSU operates during the summer, they are not all campuses, not all buildings are fully utilized or operational. So I think there are a lot of campuses right now that have heat exchangers on their heating hot water systems to provide domestic hot water to integrate the two. But there are challenges with that where some campuses can actually shut off their entire heating hot water system for 3 to 4 months during the summer. So I think it's finding a balance of integrating the systems when it makes sense for the buildings that are operational 24/7 or year round, and then trying to find ways to reduce just the time that systems are operational when possible.
Great, thank you. A question about planning for climate adaptive planning, and how are you guys incorporating extreme weather events like the Texas freeze or the polar vortex? Hopefully we don't have any of those in California anytime soon, but heat definitely, and maybe cold into the future. And how are you incorporating the expected increasing likelihood of extreme weather events into it?
Certainly, yeah. So we obviously hope that we don't have to deal with a barrage of them all at once, but we are working on a separate climate adaptive sort of design day framework that is studying and pulling information from CalAdapt as well as from a bunch of academics whose expertise we want to leverage within the CSU system to think about how we're going to design, infrastructure and buildings in 2050 to the climate that will be the reality at that point in time. So implementation there is still a little bit far off as we're still working on the study. But right now within the Chancellor's office, if your project hits a certain budget threshold, it has to come through schematic review, and we take a look at it and we'll pose questions to the campus and the engineering and architecture team saying, have you thought about it this way? Okay, well, this building's going to be around for this long. What do you think the climate's going to look like then? Do you have to make some changes to how you're designing your infrastructure so that you can make sure it's one, operational, and two, still comfortable for occupants? So certainly something that is top of mind as well.
Fantastic. A number of folks are asking about getting access to the slides and the presentation and the framework. And so For these BDC Presents, we have a members portal. It's very easy to become a member. Go to buildingdecarb.org/join, and you can join as a member of the BDC, and that you can get access to the slides and the presentation. And then people have asked for the framework, and I'm wondering, Rachel, if you'd be willing to put a link to the framework in the chat while we're going questions, and folks can go down into the chat part of your control panel to be able to get a direct link to the framework now if you're not going to get the PowerPoint afterwards. We do have a commenter here that says the CSU seems to be way ahead of the UC in terms of planning, central planning for building electrification. Warms your heart, doesn't it? Have you been in discussions with the UC? And how are cross-institutional conversations going on building decarb?
I'll start off that question, and then Andrew can probably elaborate a little bit. Yes, we have been chatting with the UCs, and like I said, the CSU is its own unique system. The UC operates a little bit differently. So yes, but we have started that conversation.
And I'll just add that UC and CSU have worked closely together, like, for example, on the partnership for the energy efficiency partnership. They do have different tacks on this, but, UC has their carbon neutrality initiative. They have a big study several years ago, which was the Tomcat study that talked about getting to zero. And so I think there are dimensions where CSU is sort of ahead of the game with some system-wide stuff, and I think there are some other areas where UC is actually, we looked to UC in the policy report, for example, and used some of what they had already done to inform our work here. So I think both systems are actually moving forward, rapidly on this front. And like that clean energy optimization pilot is another example. That was really pushed by UC with Edison, in their goals to hit carbon neutrality. And so they're both doing a lot of great work. So anyway, that's my political answer.
Well done. So as I said, there's a bunch of great questions in here. Can you talk more about using swimming pools for thermal energy storage and how you'll be going about doing that? And are you using any, say, extra large heat pump water heaters for that effort, or how swimming pools are being incorporated into the decarbonization plans?
Yeah, and I guess this hasn't something that has been implemented, but something that we'd been thinking about and talking about with different energy managers. So part of it is if there are dedicated heaters using heat pumps. Some of the CSU campuses actually also have heat exchangers tied to their heating hot water loop to heat their swimming pool, which provides an easier opportunity by selecting a larger heat exchanger. But yeah, I think in general, just the more innovative ways we can find to store and move heat around is going to be important. And domestic hot water, swimming pools, just anything that has a large water volume could be used. And yeah, I mean, swimming pools, it's a massive amount of water that's at our disposal.
Great. A number of folks were really intrigued by the tools that you showed off. The LCCA tool, I think your heat recovery tools. Are any of those open source or available to folks? Or will they at some point be made available? Is this the way that CSU can add extra revenue?
We are not selling it, but the LCCA tool is available at that link that Ashley threw into the chat. So you have to click the scope 1 dropdown. It's not just there. So if you're having trouble finding it, look to the dropdown scope 1 direct emissions. That's where you're gonna find it. The LCCA tool is part of that. I think the simultaneous heating and cooling tool we've only made available, at least the live option, only to folks within the CSU with authentication. But I can sort of work to figure out how we can maybe, we have a little bit of data concerns around that, but perhaps there is a way to let folks play with it a little bit. Maybe Glumac could take off the campus name or something, and then people can mess with it a little bit and see how it works. So that's in the future, probably, yeah.
Okay. Could they reach out to you, Rachel, for folks
Absolutely.
talking about that? Would you mind putting your email in the chat as
yes,
well?
I can do that.
Awesome. Thank you so much. A question from Mr. Ted Tiffany. This look is for Brian. Have you ever considered any cascading heat pump technologies or CO2-based heat pumps with a higher COP and temperature output?
We have, we've done that for domestic hot water systems. So supplying like 120 degrees from a new central heating hot water plant, and then using that to boost for 140 degree domestic hot water. We have not installed CO2 heat pumps. I know there are, emerging technologies out there, and that's something I think that was identified as an emerging technology that campuses should keep an eye out, since it does provide higher temperature hot water as well as more efficient, but they're definitely at a smaller scale. But yeah, I think the cascade heating is certainly a great strategy for buildings that do frankly just have existing infrastructure that make it challenging to reset heating hot water temperatures and maintain occupant comfort.
Great. How do you guys handle bacteria growth for any storing of water below 140 degrees?
So those would all be in closed loop systems. So anything on the domestic hot water would be above 140, and that's where instead of using the air source heat pump, tying onto the heating hot water return would allow you to, I guess, work around those bacteria growth concerns.
Great. And then I think we have time for two more. This from architect Scott Shell. Great work, thank you. Considering the time value of carbon, could the CSU procure low carbon electricity on a faster time scale, perhaps act as their own utility as the UC has?
Yes, we have considered that in the past. The feasibility right now doesn't quite seem to be panning out, but we are certainly not opposed to revisiting it in the future once some of those details work themselves out.
Excellent lightning round, Rachel, answer. I love that. Somebody did ask, is there a job board for CSU green jobs? So people want to work with you, Rachel, it looks like. Is there any kind of a job board specifically that outlines kind of the green jobs within the CSU system?
I don't think so. We have our sort of CSU main job board. Honestly, a lot of when you're doing work with energy managers or facilities, or even as a sustainability manager, all those are things that touch the green aspects of the CSU. But no, I don't think we have one actually explicitly carved out.
Okay. And it was only a matter of time. Embodied carbon. How are you thinking about embodied carbon at the CSU?
Well, we adhere to Buy Clean California. So, for certain construction materials, we have to make sure that folks submit EPDs, environmental product declarations. So that's where we're starting. And, I think that with the Building Decarb Framework, we're going to tackle these heating hot water systems first. And then maybe in time, we'll figure out a way to deal with that. So definitely thinking about it. Don't have a great answer for you right now, but hopefully in time.
Great. And Peter, you see Rachel's email there in the chat if you want to have a conversation with her about any good ideas you might have. With that, I'm going to pull it to a close. Rachel, Andrew, Brian, you killed it as expected. Thank you so much for taking the time. Just a ton of action on the question pane. So I know folks are engaged and interested, and just really appreciate your leadership. I mean, to take an institution like the CSU and develop a plan for the diversity of climate zones and leadership and different areas of the state is just so impressive. So thank you for your work, and thank you for joining us today. And to all of you out there who joined us, Thank you for joining us. Thank you for your leadership in decarbonization, and we'll see you out there decarbonizing, everybody. We're ending the webinar.
Thanks so much.
Thank you.